So chapter number 6 is electromagnetic induction, alternating current, I think.
Electromagnetic induction, yeah.
Oh,
Yes,
okay,
sir.
okay. Yeah, electromagnetic induction. So,
And until
so
semiconductor.
semiconductor devices.
Yeah.
Okay, no problem. Just we are studying the optics. This will also be appear some in some means when in your final exam.
Yes.
Okay, so
Yes.
don't think that you are wasting your time by joining the class. So, this will also be appears means in the final exam. Basically, the main thing is the final exam. Na? So,
Yes, sir. Yes.
hmm. So what was the last topic that I have covered in the last class? I think to check.
Sir, it's this spiral mirror, spherical mirror.
Spherical mirrors.
Yeah.
Hmm. Hmm. So basically, spherical mirrors are the mirrors which is made from spherical surfaces. You can see here, this is the spherical surface, and this spherical surface is polished uh, from this side, and you have cut it out. This portion, this, this portion you have cutted it out. This portion, okay, means I want to say this portion you have just cut it out, and basically this is the concave mirror you get. Okay, this is the polishing. Okay, here, and I think I have told you what is the center of curvature. Center of the sphere from which this concave mirror is made. Basically, this concave mirror is made from a sphere. You have cut it out from a sphere. So the center of the sphere is also the center of the mirror, and this is known as the center of curvature. And the distance between the center of curvature and the pole is known as the radius of curvature. Okay, the distance between the center of curvature and pole is known as the radius of curvature. Okay, radius of curvature. So basically, you can say CP distance is radius of curvature. Pole is a midpoint, or you can say the middle point of this mirror. Okay, this pole is dividing the mirror in two equal halves. Principal axis is basically the line joining the center of curvature and the pole. Principal axis is the line joining the center of curvature and the pole. Basically, aperture is basically, you can see here, aperture is a portion of the mirror uh, from which the reflection of the light can take place. Okay, uh, is the aperture is basically, this portion is basically the aperture. Okay, so after this I will discuss what is focus and the focal plane. What is focus and the focal plane? Hello, Nabal.
Hello, sir.
Okay, so we will in the last class I have just already told you what are spherical mirrors. So spherical mirrors are the mirrors which are made from the spherical surface, you can say, and spherical mirrors are of two types: concave mirror and convex mirror. And we will discuss focus and the focal plane. So basically we have two mirrors, concave and convex. So separately, one by one, we will discuss for what is focus for the convex, what is focus for the concave mirror, and what is focus for the Convex mirror, what is focal plane for the concave and convex, accordingly we will discuss. So already I have written to save the time. So basically for a concave mirror, what is focus? Focus is that point when rays of light, basically this is a concave mirror. Okay, this is a concave mirror. Which mirror is this? This is a concave mirror. We know that this is a concave mirror. And this is pole. This is pole, and this is okay. Remove this point just. This is the center of curvature. This is pole, and the line joining the center of curvature and the pole is the principal axis. Basically, this line is the principal axis. Okay. So, what is focus for? How we will define the focus for the concave? Basically, if rays of light parallel to the principal axis. So basically, this ray of light, this ray of light, and there can you can take any number of rays of light, 1 2 3 4 5 6 7 8, any number of rays of light, but the condition is that those rays of light must be parallel to the principal axis. So basically these rays of light, this ray of light and this ray of light is parallel to the principal axis. Basically this ray of light is coming from some object, you can say, coming from infinity also, you can say. So this ray of light is coming, and this ray of light is parallel to the principal axis, and after reflection from this, basically here this ray of light is striking at this point. So after striking here, it will bounce back or reflection will take place. Okay, reflection will take place. So basically this ray of light, suppose, is going in this direction like this after reflection, this ray of light. Now what about this ray of light? Same is the case for this ray of light after reflection. Basically now this point is focus. Basically focus is a point where the parallel rays of light, which is parallel to, which is also parallel to principal axis, meet, is a focus. Okay, so focus of a concave mirror, definition you can write this: rays of light parallel to principal axis after reflection from the concave mirror, you can write, meet at a common point on p axis, means principal axis. Basically focus is on the principal axis, called focus, called focus. And remember one thing here, as these rays of light are meeting actually at focus, so the concave mirror will have real focus. Concave mirror will have real focus. Okay, rays of light are actually meeting, so concave mirror have real focus. Okay, now we will discuss the focus for the convex mirror. This is the convex mirror. Same way to define the focus for the convex mirror. Okay, basically this is pole. Okay, this is pole and this is center of curvature and this is principal axis, and these rays of light are parallel to principal axis. Now in this case, the condition for the focus will change. For the basically this is a convex mirror. This is a convex mirror. Okay, because the reflecting surface is bulging outward. That is why this is a convex surface. Here reflecting surface is convex surface. That is why this is known as the convex mirror. So basically this ray of light and this ray of light is parallel to the principal axis. Okay. Basically this portion is the front of the mirror. This portion is basically the front of the mirror, and this portion na, is the back of the mirror, you can say, or you can say this center of curvature is lying in the mirror, or you can say, suppose this is a mirror. I want to just basically this will behave as a plane mirror. So if I say that this is a mirror, okay, if I say this is a mirror, so if I will see like this, so my image is in this. So what I will say, the my image is forming in this mirror, or I will say my image is formed behind the mirror. So it is better to say that the image is forming in the mirror, because you can say behind the mirror is no image, but in the mirror I am able to see the image. So basically here the center of curvature is basically uh, center of curvature is basically this center of this mirror, but we will talk that for the focus. uh, okay, so this ray of light incident like this, so what will happen? uh, Reflection will take place. Okay, reflection will take place. Okay, so what is happening here? This is the ray of light and incident at this point and reflected like this. Reflected like this. Okay. This is a ray of light reflected like this, and this is the another ray of light. Another ray of light. mm, Reflected like this. Okay, so okay. This ray of light reflected like this. This ray of light reflected like this. Now, this is the reflected ray. This is the another reflected ray. So you can see both the reflected rays are diverging. These are diverging like this. So diverging rays will never meet. Diverging rays will never meet. But when you will produce these diverging rays backward, okay, like this. You have produced these diverging rays backward, and this diverging ray you have produced backward. This diverging ray you have produced backward, and they are meeting at a common point. They are meeting at a point, and that point is known as the focus of convex mirror. Focus of convex mirror. So this is the definition. Rays parallel to the principal axis. Rays parallel to the principal axis. After reflection, after reflection, after reflection, diverges, diverges. The divergent rays, the divergent rays on being produced in backward meet at a common point. So on being produced backward meet at a common point called focus. So this is the focus for convex mirror. After that we will discuss the focal plane. Focal plane. So what is the focal plane? So suppose parallel rays of light, these are the parallel rays of light. Okay, so and which mirror is this? This is a concave mirror. This is pole, and somewhere here will be the center of curvature, you can say. So reflection will take place. Reflection will take place. So basically, this ray of light, okay, this ray of light will be reflected, suppose like this, and this ray of light is reflected, suppose like this. Okay. So center of curvature, I think. Okay, you can just center of curvature is here. So these parallel rays are meeting at this point, and these parallel rays, but these parallel rays are not parallel to the principal axis. These parallel rays are parallel to itself, and these are meeting at this point, and this point will lie on the focal plane. Okay, will lie on the focal plane. Basically, we can draw focal plane like this. Okay, so this is suppose point B. At point B, these parallel rays are meeting. So this point B is lying on the focal plane. So basically, this is what? This is focal plane. Okay, so focus will also lie on the focal plane. So somewhere here will be focus. So what can we say about the focal plane? Focal plane is a plane on which the parallel rays of light meet at a point. Set of parallel rays of light after reflection. Set of parallel rays of light after reflection from a concave mirror meet at a point. This is a point. Always lie in a plane. Okay, this is a plane basically. Always lie in a plane called focal plane. Okay, so okay, so if this is a condition, then you know what will happen. This point will be the focus point, and you can say this focus is will also lie in the focal plane. Because these rays are also parallel rays, that is why these rays are meeting at a point on the focal plane. So basically this is a focal plane, and this is pole, and this is focus, and somewhere here will be the center of curvature. So basically this is a focal plane for a concave mirror. Okay, now we will discuss the focal plane for the convex mirror. So this is a convex mirror, and these are the parallel rays, and this is the principal axis. Convex mirror is there. These are the parallel rays, and these parallel rays are striking the mirror like this. Okay, so reflection will take place. Okay, so For the first ray, suppose this ray is going like this, and this will be reflected like this. Okay, reflected like this, and another ray is this, and suppose this is reflecting like this. Okay, this is reflecting like this, and like this. So now when you will produce these rays backward like this, reflected rays, or you can say diverged rays, when you will produce backward, these rays will meet at a common point on the focal plane. This is a point B. Okay, and so basically this point B will lie on the focal plane. Oh, sorry. Okay, so basically this is a focal plane for convex mirror. Okay, set of parallel rays, set of parallel rays. These are the parallel rays. So a set of parallel rays after reflection. So after reflection, this ray after reflection is going in this direction. This ray after reflection is going in this direction. Diverges. So both rays are getting diverged. So this ray is also diverged, and this ray is also diverged. Both rays are getting diverged, and when you will produce these rays, these diverged rays in backward direction, so these rays will appear to meet, not actually meet. Produce backward. So you can write here appear to meet. So it is already written produce backward. So you can write meet also. So produce backward, meet a common point. These points always lie in a plane called focal plane. Okay. So this is a focal plane for a convex mirror. Focal plane for a convex mirror. And have I told you the focus for the convex mirror? Okay, convex mirror. Okay. So Nafisa, can you tell me this convex mirror have a real focus or virtual focus? This convex mirror. Hmm?
Virtual,
Why?
because it's behind the
You are right, but
mirror.
you can say that it is behind the mirror or it is inside the mirror, or you can say that
Yes,
these rays are not actually meeting. Okay, so that is why this have a virtual focus.
virtual. Yes, sir.
Hmm. Virtual focus. Okay, so you all of you can take the screenshots. Okay, just a minute. I am just zooming it out. Now you can take the screenshot one by one and arrange the screenshots properly, because when you will draw this on copy, it will take time. So you can take screenshots, and when completed the screenshot, you can just ask me to scroll down.
Yes, sir. Scroll down.
Okay.
Yes, sir. Done.
Okay.
Yes, sir.
Hmm.
Yes, sir.
Okay. Completed.
Yes, sir.
And Nabal, you also completed this.
Yes, sir.
Okay, so this is clear basically what is focus and what is focal plane. Focus is where focus we can define in a way that when parallel rays of light, parallel rays means rays are itself parallel and parallel to the principal axis and meeting at a common point on the principal axis, that is on the principal axis, that is known as the focus. And what is focal plane? Focal plane means parallel rays of light. No matter these rays can be parallel to the principal axis and cannot be parallel to the principal axis. So basically, we can say parallel rays of light after reflection meeting at a common point, and that common point is lying on a focal plane. So focal plane is a plane on which the parallel light rays after reflection will meet or appear to meet. Appear to meet, we will say in case of the convex mirror. Okay. Okay. So after this, we will discuss a thing that you have already studied in your 10th class, but I know that you don't remember. Okay. Laws. There are some rules or sign conventions. Okay. And these sign convention for solving the numerical and for this chapter is very, very, very important part. So understand these concept or these just a statement of the sign convention. Okay, you have to just learn this thing. First point in sign convention, and why we are studying the sign convention. The reason is that actually we have to put, suppose this is a mirror and this is the object. So there is a distance between the mirror and the object. So now this is the condition, means this is the question, from where we will measure the distance. We can measure the distance from the focus of the mirror also, from the center of curvature of the mirror also, from the pole of the mirror also. So it is said that in sign convention that we have taken the in sign convention always the distance is measured from the pole. Remember this point. Always all the distances will be measured from the pole. First point. Okay. Another point. Another point. So this is the point, the direction of the incident ray is taken as positive and any distance measured around the incident ray is positive and measured opposite to it is negative. Okay, now I am explaining this point with the help of an example. How it will happen. Hmm. Okay. Now look carefully with proper concentration. This is a concave mirror and this is a convex mirror. So from the polishing you can, this is a polishing surface. From the polishing you can decide the mirror is concave or convex. Okay. Or you can decide from the reflecting surface also depending upon you. Okay. So now suppose the light is incident like this. A green color light is incident on the mirror, is going towards the mirror. This is the incident light. So basically this is the incident light, or you can say incident ray also. So in this sign convention, point number second, the direction of incident light will be taken as positive for measuring the distance. So here, mm, in this case, you will take this distance in this direction. If you will measure the distance in this direction, so you will take positive. Okay. And if you are measuring the distance in this direction, then you will take the distance as negative distance. But distance can never be negative, because distance is some length. Length can never be negative. But this is a sign convention, so we will take distance negative or positive here. But remember, distance can never be negative. Okay, now suppose one object is placed here. This is the object. Okay, for this mirror, suppose here a object is placed. This is the object. Okay, O is the object. This is the object placed, and okay, here is object. This object placed. Now I want to measure the distance of this object. So from where I will measure the distance? From pole I will measure the distance. So how I will measure the distance? You can see I will measure the distance like this. This is the pole. So basically I can take, okay, like this. I can say this will be the distance. So basically this is the object distance u. Small u is the object distance, and you are measuring the distance in this direction, and from the pole you are measuring. Now you are measuring the distance in this direction, so this distance will be negative now. In this case, this distance will be negative. And what is the u? What is the small u? Small u is the object distance. The distance of object. And object distance, obviously all the distance we will measure from the pole. So this is the incident light. Now this, for this mirror, suppose this is the object, and from this object this is the incident light. Okay, so this is the incident light, and this is basically the object. Okay, this is straight line thing. The straight line is representing the object. So this is the incident light from the object, incident ray, or incident light, you can say, incident ray also you can say. Okay, so again, this direction of measuring distance you will take positive, because direction of incident ray is taken as positive for measuring distance, and when you will measure the distance along this direction you will take negative. Suppose of this object, here the image is formed. This is the image. Basically this is the image of this object. Here is the image formed. For example, suppose here is the image formed like this. This is the image. This is the object and this is the image. Now if you want to measure the object distance and image distance, and always you will measure the distance from the pole, you know this very well. So from the pole you will measure the object distance. So this will be the object distance. So object distance u, this is object distance, and you have measured this object distance opposite to the, means you have measured the distance in this direction, or you can say you have measured the distance in the opposite direction of the incident ray. So this distance you will take negative. Okay. Now you want to find the image distance. So this will be the image distance, the distance of pole, and the image is image distance. So you have measured the distance in this direction. Okay, from pole to the image. You are going from pole to the image. You are measuring the distance in this direction. In this direction, image V is known as the image distance, and this will be positive. Why this is positive? Because you are measuring in the direction of the incident ray. What is V here? V is the image distance. Image distance. I think this is clear now. Second, third and last point. If the height above the if this is the principal axis, okay, this is P axis. So P axis means principal axis. So height, if you will measure the height above the principal axis, then that height you will take positive, and height below the principal axis you will take negative. Okay. So this is the sign convention. These are the sign conventions that you will use and we will use throughout this chapter. Throughout this chapter, we will use these sign convention. Okay. So now you can take the screenshot again.
Yes, sir, done.
Okay. And remember O for object, I for image.
Yes, sir, done.
Okay. So all these things we will use in the upcoming topics. So okay. So now we will discuss. There are some rules for the image formation. For the image formation means for making the ray diagram, there will be certain rules. Ray diagram means when you will obviously when you will place the object in front of the concave or convex mirror, image will form obviously. So to show that image on the paper or here on the screen, there is a requirement of the ray diagram. So for the image formation, there are certain rules for the convex mirror as well as for concave mirror. So first we will discuss some rules of reflection for concave mirror. Very simple rules. Okay, the first rule is that this ray of light, this is the principal axis, you know. Okay. Uh, Nafisa, are you getting the cursor motion? This plus sign motion?
No, sir, it's not moving now.
It's not. It now also it's not moving.
No,
Okay.
it's not.
Now.
Yeah, now.
Okay. So basically, this is the principal axis, and this is a ray of light, and this ray of light is parallel to the principal axis. So what will happen if a ray of light is parallel to the principal axis? It will always pass from the focus after reflection. First rule. Second rule is just reverse of this. If a ray of light is passing from the focus, if a ray of light is passing from the focus, it will become parallel to the principal axis. Second rule. Third rule. If a ray of light is passing from the center of curvature, it will retrace its path. Center of curvature, after reflection, ray of light passing from the center of curvature, and after reflection from the mirror, it will retrace its path. And if someone is asking that the reason why it retraces its path. So you can say that normal, when you will draw the normal for this, so normal will also pass from the center of curvature, because in the spherical mirrors, normal always passes from the center of curvature. In the starting of the lecture I have told you. So when you will draw the normal, so this is a normal, na? So when you will draw the normal will be like this. So angle of incidence is equal to 0. Okay. According to the law of reflection, angle of reflection is also equal to 0. So angle of reflection is equal to 0. That is why this ray of light will retrace its path. When this light is going in this direction, it is making an angle of 0 degree with normal. This is a normal. Okay, you can consider this as a normal. When a light ray is going in this direction, again moving along the normal, na, the angle of reflection is also 0. And there is another, uh, basically these are three basic rules, and there is one additional rule. Then you can, okay, this is the center of curvature, and this is a ray of light. Now if you want to draw the normal, so normal will pass from the center of curvature. So basically you can say this principal axis will behave as a normal, or when you will draw the normal, it will coincide with the principal axis. Basically this is the principal axis. When you will draw the normal, you know that the normal will pass from the center of curvature. So normal and the principal axis will coincide, and this is the normal. Suppose this is the angle of incidence, this is theta. Okay, and this ray of light is striking on the pole, and this is the angle of incidence. So after striking from the pole, this ray will be reflected, and in this case this angle of reflection will also theta. Why? Because this is the angle of incidence, this is the angle of reflection. Okay. Because this is the normal. So four rules will be used to form the image by the concave mirror. Okay, so so these rule I will use. This first rule always I will use, always. First rule to draw the every image of object, I will use first rule. This first rule is very, very important. But you should know all the rules. And which mirror is this? Concave mirror, obviously. Okay. So, okay, first take the screenshot, then we will discuss the image formation by the concave mirror for different positions of object.
Yes, sir. Done.
Done. Okay.
Yes, sir. Done.
Okay.
Done, sir.
Okay, so now we will have a concave mirror. We will have a concave mirror, and for example, now what we are going to do basically. This is a concave mirror. This is a principal axis, and this is suppose focus. Oh, actually, I have not told you about the focal length. Okay, so I will tell you later about the focal length. This is focus and this is the center of curvature. Okay. This is center of curvature, this is focus and this is pole. Okay, so first we should discuss the focal length. So we will discuss focal length. Focal length. Length of focus means the distance between the focus and the pole is known as the focal length. Simple. But here some concept will use that you should know. This is focus, this is pole, this is center of curvature. Center of curvature, focus and pole. Okay. And suppose a ray of light is like this. A ray of light is striking on the mirror like this. Okay. This is the incident ray. Okay, this is the incident ray. Now normal, there is a requirement of normal now. So normal will pass from the center of curvature. We know that very well. So we will draw the normal like this. This is the normal. Remember, this normal is very, very important point. Okay. How to draw the normal in case of spherical mirror. In case of plane mirror or plane surface, to draw normal is not a big deal. But here you will get sometimes confused. But always remember, normal will always pass from the center of curvature. In case of spherical mirrors, if you have a sphere, it will pass from the center. If you have a circle, it will pass from the center of that circle. So this is a normal. So the angle made by the incident ray with normal is the angle of incidence. Suppose angle of incidence is theta. Okay, suppose angle of incidence is theta. So obviously this ray will reflected back also, reflected also. So according to the angle of reflection, suppose this ray is reflected like this, no problem. Mm, actually, fine. In our syllabus, basically we will discuss mirrors of small aperture. Mirrors of very small aperture. Mirrors of very small aperture. Aperture means, suppose if you are taking this mirror, okay, so a small aperture means, if you have this system, a small aperture means this mirror will be very, very small like this, and like this also, and like this also, very small aperture we in our syllabus. So now where is the angle theta? This angle, now this angle, this theta is looking, means here. Now here when the mirror of small, not that small, I am saying, but the small aperture, now you can say theta is increasing, not small aperture, theta is decreasing. So basically for small aperture, very small aperture, this theta is also very small. Theta is also very small. So theta will be very small. So this theta will be very small. And what is focal length? Focal length is basically the distance between pole and focus. distance between okay. So here theta is very small. Why? Because aperture of the mirror is very small. And what is focal length? Focal length is the distance between focal length of focal length of any mirror, concave or convex, is the distance between the focus and the pole. Or you can say the distance between the pole and focus. Distance between pole and focus. And focus. And this focal length is represented by small f. This is f and this is small f. Okay. So remember this point. And there is a derivation, but I am not doing that derivation here. There is no requirement of that. So the formula to calculate the focal length is equal to r minus r by 2 sec theta. R minus r by 2 sec theta. Okay, so basically na here na you have to you have to change that thing little bit. This ray will be parallel. Then we can drive this. This ray will be parallel like this. Okay, so we can take the parallel ray like this also. No problem. So this angle is theta. Okay, so accordingly the angle of this will also change. So it will pass from the focus. So it will pass from the focus. Okay, no problem. So basically this is the formula for the focal length. But this theta is very small, as aperture is very small. If theta is small, then you can write sine theta as theta. If theta is small, you can write sine theta approximately equal to theta. For example, I am saying sine of pi by 3. Sine of any radian you can take. If that angle is very small, suppose sine of 0.005 radian. So you can write this value is equal to 0.005. Okay, so this in this way you can do. Now for cos, if theta is very small, so cos theta can be written as 1. Because if theta is very small means theta is approaching to 0. So theta is very small means theta is approaching to 0. So cos 0 is equal to 1. Now we know that sec theta is equal to 1 upon cos theta. So if cos theta is equal to 1, then sec theta also you can write approximately equal to 1. So basically for a small aperture, for mirrors of small aperture, this formula will change. Basically what we have here, we have focal length f is equal to r minus r by 2 into sec theta. So sec theta can be written as 1. You can write sec theta approximately equal to 1. So this sec theta will become 1. So focal length is equal to r minus r by 2. And I have not told you what is r. Earlier I have told you, basically r is the distance between the radius of curvature. Basically r is the radius of curvature. Okay. So basically distance between the pole and the center of curvature is the radius of curvature r. Okay. So r is the radius of curvature. So r minus r by 2. So focal length is equal to r by 2. So focal length is half of the radius of curvature for our mirrors of a small aperture, and mostly we will study the mirrors of a small aperture. So this formula is very important. You should know focal length is half of the radius of curvature. Okay, so please take the screenshots of this point, this focal length. This is the incident ray.
Yes, sir, done.
Okay. And okay, now take this screenshot. Then we will discuss the image formation. Now you know what is focal length. Focal length is basically half of radius of curvature for the small for the mirrors of small aperture. So image formation for the concave mirror. Uh, Before that, this is focal. This is center of curvature. So what I will do now? So suppose object I have placed here. So this is the object position first. We will shift the object. First the object is here. This is the initial position of the object, and we will see where the image will form and how the image will be. Will it be real? Will it be virtual? How the size of the image as compared to the object? All these things we will discuss. First we will uh, place the object beyond the center of curvature. Then we will put the object on the center of curvature. Then again we will see. And how we will see? We will draw the ray diagram to analyze how the image is forming. And after that we will place the object between the center of curvature and focus. And after that we will put the object at focus, and we will see the where the image is formed. And after that we will put the object between the focus and the pole, and we will see what will be the image and how are the characteristics of the image. So first case I am taking, I have just placed, this is the object and this is placed beyond the center of curvature, or you can say this is placed in between the infinity. This is the infinity somewhere, and infinity and center of curvature. Okay, now remember one point: to draw the ray diagram, or to form the image, at least two rays must meet at a point or appear to meet at a point. Okay, at least two rays from the object must meet at a point or appear to meet at a point. Then the image will form. So if I will ask, can this pen give the light? Can this pen give the light, Afisa and Nawal? Can you tell me?
No.
This pen cannot give the light. Okay. Can bulb give the light? Gives the light?
Yes.
If I will say this pen can give the light, so how? See how this pen can give the light. Light is coming from this bulb, this bulb, this bulb. Three bulbs are there. So light is striking on this pen, and this pen striking, after striking, this pen is reflecting the light. So basically indirectly this pen is giving out the light. So basically you can say that this pen can give the light. And basically this is explained by the concept of luminous and non-luminous objects. So basically this pen is a non-luminous object. This pen have give the light, but this pen does not have its own light. Okay, like sun have its own light, bulb have its own light. Star have its own light. Moon does not have its own light. This pen also a non-luminous hmm, non-luminous object. Huh. So basically, any object that you are able to see is giving out the light, basically, directly or indirectly. Okay, that's how now you are able to see the image of any object. Otherwise, how you will see if that object is not giving you the light? We are able to see the object either by refraction, either by reflection. Okay, so for that there should be the light from the object. Okay, now see, this is the object basically, and two rays will be required. So from this object, first ray I will draw parallel to the principal axis, like this. First ray of light is parallel to the principal axis. This is the first ray of light from the object, and basically this is the object. Now after reflection, you can see here it will pass from the focus. I have told you that I will use, if a ray of light is parallel to the principal axis, it will pass from the focus. So here ray of light is parallel to the principal axis. Now it will pass from the focus. Now it is passing from the focus, no problem. After reflection, is passing from the focus. Okay. Another rule I have told you, that when a ray of light is passing from the focus, it will become parallel to the principal axis. So two rays are required. So first ray is parallel to the principal axis and passing from the focus. Second ray I am drawing like it is passing from the focus. It is passing from the focus, and after reflection from the mirror, after reflection from the mirror, it will become parallel to the principal axis. Okay. Now where two rays are meeting, these two rays are meeting here at this point. These two rays are meeting. So basically, this will be the image of the object. Arrow is downward. Arrow is in downward direction. So here these rays are meeting. So this will be the image of this object. So this is the way to draw the ray diagram. Okay, now we will see the characteristics of the image, size of the image, and the position of the image. Position of the image is very clear. The image is formed in between the center of curvature and the focus. After that, what is the nature of the image? The nature means real or virtual, inverted or erect. So now here rays of light are actually meeting. So this image will be real image. And now see this arrow. If the object is like this and image is like this, so it means that this image is inverted. We show the inverted image like this. So it is clear, image is formed between the center and the focus, and it is real and inverted. Okay, now see the size of the image as compared to the object. From the ray diagram, it is clear that the size of the image is less as compared to the object. Basically, the size of the relation between the size of the image and the object is given by the magnification. So separate topic we will have the magnification. Okay. So basically image is formed between C and F, real and inverted. Diminished. Why real and inverted? Because rays are actually meeting. Rays actually meeting after reflection. Okay. Diminished means smaller than object. Image is smaller than object. Now this magnification we will have a separate topic, but here I am just telling you the basics. Magnification means how much the image is larger than the object, or how much the image is smaller than the object. Basically the magnification is equal to the height of the image divided by height of the object. Talking about only the magnitude of the magnification, mod m is equal to mod of height of image divided by mod of height of object. Mod means if I am writing -5, so mod of -5 is equal to 5. So this mod is basically representing only the magnitude or the numerical value. Okay, so this point should be noted. And now we will see what will be the magnification here. Sign of the magnification. So magnification is equal to height of the image and height of the object. So now see, image is below the principal axis, so height of the image you will take negative. So here you will take negative, and object is above the principal axis, you will take this height of the object as positive. So negative by positive means if I am writing -5 divided by 4, so it will always be negative. It will be always be negative. So you can say the magnification is negative. Magnification is negative. Okay, so now magnitude of the magnification. So height of the image is less. This height of the image is less than the height of the object, means this quantity is less than this quantity. For example, if I am writing 4 divided by 5, it will always less than 1. Okay, so magnification here is less than 1. Okay, magnification is less than 1 because height of the image is less than height of object. Okay, so now another case, we have placed the object here. Now we will shift this object to the center of curvature, and we will see where the image will form and what will be the characteristics of image, what will be the size of the image. This is the object, and two rays will be required. So I am drawing two rays. First ray is parallel to the principal axis. After reflection, it will pass from the focus. Okay, another ray is passing from the focus. After reflection, it will become parallel to the principal axis. Okay, somewhere here this ray will meet. So basically, the image will form here. Here the image will form. So this is the incident ray, This is the reflected ray, this is the incident ray, and this is the reflected ray. Okay. And now where the image is formed? At center of curvature. The position of image is at center of curvature, and this is real and inverted. And here at this image is of same size as the object. And what will be the magnification? Magnification will be negative because height of the image is negative, height of the object is positive. Magnification is negative, and magnitude of the magnification is equal to 1. Okay. So here you can write for the magnification. So magnification is equal to negative, and you can write the mod of magnification is equal to 1 because height of image is equal to height of object. Now we will place the object. Basically, this is the object here. This is the image. We will place the object between center of curvature and focus. So this is object between the center of curvature and focus, and we will see where the image will form. So first way is parallel like this, and will pass from the focus after reflection. And now another ray is passing from the focus, and becomes parallel to the principal axis, after reflection. So basically image will form beyond the center of curvature. Okay. So when you will draw this diagram, by using the scale, okay, so this will be more correct. Okay, this will be more correct. So this is the incident ray, this is the reflected ray, and this will be the image here. So image will be this. Basically this will be the image. This will be the image. Now you can see the size of the image is greater than the size of the object. Size of image is greater than the size of the object, and again you can say rays are actually emitting, so it will be real. And with real you can also say it is inverted also. Real and inverted, forming beyond the center of curvature. Magnification we will see. So image is formed beyond center of curvature. It is real and inverted, and it is magnified. Magnified means larger than the object. So magnified means larger than the object. So magnified means the larger than the object. Larger than object. So now you can see here why the magnification is negative. Magnification is height of the image divided by the height of the object. So height of image below the principal axis image is formed negative, and height of object is above principal axis, so you will take positive. So finally it will be negative. Magnitude of magnification is equal to mod of height of image divided by mod of height of object. This time height of image is greater than the height of object. That is why magnitude of magnification is greater than 1. Remember one point is, if image is real and inverted, then magnification is always negative. Okay. Now we will place the object as at focus, and we will see where the image will form. So first ray of light parallel, after reflection it will pass from the focus. Now another ray here, we will another ray will pass from the pole, and after that it will become parallel. Okay. So this is the pole here, and if this angle is theta, this angle will also be theta. Earlier I have told you. So now you can see these rays are the parallel rays, and parallel rays meet at infinity. Meet at infinity. So basically here you can see image will be real, image will be inverted, and the size of the image is very large as compared to the object, and image is formed at infinity. So image is formed at infinity, it will be real and inverted, highly magnified, very large than object, and magnification is negative, and magnitude of the magnification is much greater than 1, because height of the image is much greater than the height of the object. Height of the image is much greater than the height of the object. Okay, now this case is a different case. Basically now see here. Okay, so first we will draw the image, then we will discuss. So now we have placed the object between the focus and the pole, focus and the pole, and focus and the pole. Suppose this object is giving the green color right this time. Okay, so this is the incident ray parallel to the principal axis. After reflection, it will pass from the focus. After reflection, it will pass from the focus. Now another ray. Okay, this is the incident ray parallel to the principal axis. After reflection from the mirror, it will pass from the focus. Oh, sorry, it will pass from the focus. Okay, so it will pass from the focus is here. So it will pass from the focus like this. It will pass from the focus. Another ray from this object is striking on the pole and is going like this. Okay, if this angle is theta, then this angle will also be theta. Now these are the diverging rays. These are the diverging rays. Diverging rays we are getting. In reality, diverging rays will never meet. So what we have to do for the image formation, we will produce these rays backward. We will produce these rays backward. So okay, so here somewhere here the image will form, and you are producing these rays backward. So here you are getting the image. Okay, and now this time you are getting the image like this. Okay, now sign of the arrow is like this. This is the object, this is the image. Okay, now you can see here these rays are not actually meeting, these are just appearing to meet. Actually we have just produced the diverging rays in the backward direction, and these rays are meeting in the mirror. So basically we will get the virtual image. And now see, if this is the condition, this is object and this is the image, then this image is upright image or erect image. We call it upright or erect. So this is the virtual and erect image, it is clear, and this image is in the mirror, forming in the mirror. Another point, the size of the image is larger than the size of the object, and magnification we will see formed inside the mirror, virtual and erect. Why the virtual and erect? Because the rays are not meeting actually, rays are appearing to meet. Rays are appear to meet. Magnification is height of the image, height of the object. This time height of the image will also be positive, height of the object will also be positive. So magnification you will get positive. Mod of magnification, again you will get greater than 1. Why magnet? Because height of the image this time also is greater than the height of the object. There is one last case when the object is at infinity. So from infinity, always parallel rays are there. From infinity, we get from object at, this is the last case, okay? After that, this is the last case of this class also. After that, we will finish this class. From object at infinite, we get parallel rays. Parallel. So here the object is at infinite and we are getting the parallel rays. So basically here, this is the incident ray. Okay, so basically image will formed at, this is the image formed at the focus. Okay, and this image is uh, inverted and real because, okay, so with real you can say inverted also. If any image is real, it is inverted also. Another point you can say uh, real and inverted, and the image location of the image is formed at the focus. Okay, and magnification is very much less than 1 because this image is point size image, very small image. So formed at focus, real and inverted, highly diminished, point size. Magnification, height of the image, height of the object. So magnification you can say in this case uh, because image is, I have told you here, I think I have told you, image, if the image is real and inverted, then magnification is negative. So here what type of image is there? Real and inverted, so magnification will be negative. Okay, and magnitude of magnification less, much less than 1. Okay, after that, as distance of the object beyond c increases, the size of the image decreases and the image shifted to the focus. Okay, so now if you are placing an object and you are increasing the distance of that object beyond the center of curvature, the image will shift it towards the focus. Okay. And now you can observe that now here see, here you are getting, in this case, everywhere you are getting virtual real and inverted, but in this case you are getting, in this case when you are placing the object between focus and pole, you are getting the virtual and erect image. Okay, so as the object move to the focus, image shifted to infinity and size of the image increases. Okay, so you can see here object is shifted to the focus. See, size of the image is this, again size of the image is little increase, object is shifted to this side, the size of the image is again increased, object is again shifted to this side. Okay, so size of the image is again increased very much when object is shifted to again to the focus. Okay, so please take these screenshots fast. Okay,
Yes, sir. Finish.
finish. Okay, so take this.
Yes, sir. Finish.
Okay, Nawal, you also take the screenshot.
Yes, sir.
Done.
Yes, sir.
Okay.
Yes, sir. Finish.
Okay.
Yes, sir. Finish.
Okay.
Yes, sir. Finish. Yes, sir. Done.
Okay.
Yes, sir. Done. Yes, sir. Done.
Okay.
Done, sir.
Done?
Yeah.
Done?
Yes, sir.
Okay. So, this is the case.
Yes, sir. Done.